Hi, my name is Marcel, and in this problem we're going to solve a problem from the exam. This is the problem 1, and it's about the Uncle Scrooge yacht. It says that Donald Duck and his nephews managed to sink the Uncle Scrooge yacht, and as this is a comic book, they want to float the yacht again with ping pong balls. So we're going to solve this problem. So in this problem, we are first asked to find the buoyant force of a ping pong ball, and then the number of balls required to float the yacht. So, well, for the first part, we need to remember that buoyant force is equal to the density of the liquid times the displaced volume times gravity. So, in order to calculate the buoyant force of the ping pong ball, we are given its volume and its mass. So we will just need to substitute. This is in water, so remember that the density of the water is 1,000 kilograms per cubic meter. So we just need to substitute 1,000 times the volume, which is 3.35 times 10 up to the minus 5th power in cubic meters, times gravity, which is 9.81, and then we have that the buoyant force of the ball is equal to 0.3286 newtons. So now we have the buoyant force of one ping pong ball. So I will write this over here. So now we have calculated the buoyant force of one ping pong ball. So now we need to know how many balls do we need in order to lift the boat again to the surface. So as we want the yacht to be in equilibrium, we can say that the buoyant force will be equal to the weight, which is mass times gravity. But we are considering not just the yacht, but the ping pong balls too. So this needs to be the total buoyant force times equals the total weight. And the total buoyant force will be the sum of the buoyant force of the ship plus the buoyant force of the ping pong balls. So total buoyant force would be equal to we will define as n the total number of balls that we need in order to lift the boat. Buoyant force of the boat plus the buoyant force of the ship, of the yacht. And our total weight would be equal to the total number of balls times mass times gravity plus the weight of the ship. And we can take gravity out of this equation, so it will be the total number of balls times the mass of each ball plus the mass of the yacht, all this times the gravity. So now we just have to equalize our formulas. So we will have that number of the force of the balls plus the buoyant force of the yacht is equal to the number of the total number of balls times the mass of the balls plus the mass of the yacht times the gravity. So this one, our buoyant force of each ball, we have already calculated in the first part of this problem. So we will just need to substitute this in here. And well, the buoyant force of the yacht will be equal to the density of the liquid times the displaced volume times gravity and on the other side we have the same. Now we need to calculate the volume of the yacht, but remember that density is equal to mass time per volume, so we just solve for volume, and we have the volume is the mass over the density, and we are given here that the mass of the yacht is 4,500 kilograms, and the density of the steel, which is the material that the yacht is made of, is equal to 7,800 kilograms per cubic meter. So we just now we will rewrite this as the volume, which is mass of the yacht, density of the steel times gravity So now our equation will look like this, and now we just need to solve for n. Well, we need to substitute all our values that we have. The buoyant force of each ball, we have it already here. The density of the water, that is 1,000 kilograms per cubic meter. The mass of the yacht that we have, the density of the steel that we have, gravity, which is our constant, the mass of the balls that we have here, and the mass of the yacht again that we have in here. So we have everything. Our only variable is n, so we need to solve for n, and once we substitute everything and solve for n, we will have that the total number of balls required to float the yacht again would be 127,373 balls. So that's how you solve this problem. Thanks for watching.